If you want to make images with your own concepts using Stable Diffusion, then one of the new kids on the block is LORA. In very simple terms, LORA gives you the quality of Dreambooth, but with the portability of the textual inversion files, all thanks to that tiny file size, which is about 6 meg in the case of LORA. LORA is also a little bit faster and can use less VRAM than the original Dreambooth. One slight drawback, however, when using the automatic 1111 web UI is that we do need to merge this 6 meg LORA file with another checkpoint and therefore create the 2.6 gig checkpoint file once again. However, in the future, it may be that we can just use that smaller file size. I'm using the automatic 1111 web UI with the Dreambooth extension, which is a little bit behind the main repo, but I've got whatever version is the latest today, which is the 22nd of December. I've got a whole load of settings, so let's start right at the beginning. If you haven't done so already, you'll want to install the extension by going to the Extensions tab, then going to the Available tab, clicking Load From, finding the Dreambooth script, and then clicking Install. I, of course, already have it installed, as you can see there. And if you want to update it, you can just click the Check for Updates button, and then if it does need an update, it will tell you there. You can apply and restart the UI. One thing to note about installation is if you are letting automatic 1111 control all your installations for everything, I'm doing everything manually, so I didn't have to do this, but if you are doing that, then you will need to make some slight changes. As mentioned in the installation instructions on the repository, there are some example web user files there, both a .bat for Windows and a .sh file for Linux, and these show how you can set a custom requirements file which is needed for this particular extension. Additionally, after you've installed it, you may want to set another environment variable, the Dreambooth skip install one, to true. As this extension comes with a couple of different options, I've done a number of different tests. I also noticed that my system VRAM monitor was consistently around 2 gig higher than the VRAM usage indicated by the program, so I'm guessing there's some caching or some such going on there. You'll have to let me know if the 5 gig VRAM settings, which I'll show you in a moment, do actually run on your 6 gig VRAM card. These are the settings that I found to work pretty well when trying to go for the fastest training, but also with a reasonable quality. Some of these statistics from my test runs, they're the first model, which is the EMA checkpoint, but I haven't extracted EMA and I didn't tick the use AMA box. As you can see there, that's using 18.8 gig of VRAM and finished in around 17 minutes and 30 seconds. The loss there, 0.236. If I do the same thing again, but this time I did extract EMA and I did tick the use EMA box, the memory usage has dropped slightly. It's down to 17.5 gig, taking a little longer at almost 20 minutes, but with a loss of 0.244. Another thing to note with the original Dreambooth is that the checkpoints are automatically created. These are the settings that I use for Dreambooth with LORA. Again, the same 10 image dataset, 300 steps per image this time, so 50 more. Batch size of 10 seems to be a lot more memory efficient. I can push that batch size all the way up. Learning rate doesn't count in this case because we've just got the LORA UNet and the LORA text encoder. Now here I've put the UNet training up to, well, a lot. It's about 9 times what they suggest on the web page. But I am also using a learning rate scheduler there. Either cosine or polynomial, either seem to be fine. I've used both. Very difficult to tell the difference between the two. Both of them seem good. For the absolutely minimal VRAM settings, again with LORA, we've got the 10 image dataset still, 300 steps per image, so that's all the same. Batch size of 1 this time, so right down to the very minimum. Of course, the UNet and the text encoder training I'm leaving the same as with the scheduler and the warm-up steps. Resolution 512. So dropping the resolution will use a little bit less VRAM. Using 8-bit Atom, that uses even less VRAM. Xformers, no text encoder, so that uses even less VRAM. And I am caching the latents. In this particular case, it got all the way down to 5 gig. If you do have a 6 gig VRAM card, let me know if that one works. I'm not sure. Like I mentioned, my system VRAM check says that's actually 7 gig. But it outputs there as 5 gig. I'm guessing there's some caching going on there in automatic 1111, so I can't say for sure if that will actually run on a 6 gig card. Now, the basic process for using Dreambooth, this particular extension, is very, very similar to the original GitHub repositories that it uses. However, one thing that is different is that you will first need to create a model. This is fairly simple. You just have to enter a model name there in the Create Model Name box. If you want to import a model from Hugging Face, you can do. That's absolutely fine, but just give that any name you want, and then your source checkpoint. I've got lots of checkpoints, and the one I used obviously is the EMA pruned checkpoint for the EMA tests and the non-EMA pruned for the non-EMA tests. So pick whichever checkpoint you want, and if you've got one with EMA weights and you want to extract them, then do that. Click Create, and that will create a model with the name, and then you can pick it up there. Once you've created your model, it's time to move on to the next tab, which is the parameters. I've already been through the ones which I think are best for these particular options, but I'll just go through each of these now. Training steps and max training steps basically control how long you want to train for. Just use one or the other. Personally, I prefer training steps per image. If you want to pause after a number of epochs, you can do. I've not found a use for that personally yet, and there is a setting there for the amount of time to pause as well. If you want to save intermediate checkpoints, personally not something I do, but there you can use lifetime steps or click the save preview checkpoint every epoch. Batch size, very much up to the amount of VRAM you've got in your GPU, but if you can make the batch size the same size as your dataset, that is quite good. Higher batch sizes run through faster. Learning rate, as mentioned before, I've already picked those optimal values, but there, that first learning rate is just for the original Dreambooth, and then you've got the two settings if you are using LORA. Scale learning rate, if you turn that on, that will change the learning rate based on your batch size and a number of other things. Personally, I always leave that off, so it uses the learning rate that I have set. There's a number of options there for the learning rate scheduler. If you want to learn a little bit more about the learning rate scheduler, then there is a very good Hugging Face page on that, which is essentially what this uses. So there we see we've got a constant with warm up. So the warm up for a number of steps there, it just builds up to the learning rate you set, and then it's just constantly that learning rate. Or there's another one there. So have a look at that page, have a look at all the different graphs. There's cosine with restarts, for example. So there's lots of different options for that. Personally, I like constant for the original Dreambooth, and then either cosine or polynomial if I am using the LORA option. Typically, I don't use any warm-up steps personally, so I set that to 0. For the resolution, typically I pick the native resolution of the model that I'm using, so 768 in this case for Stable Diffusion 2.1768V, but you can train on a smaller image resolution as well. If your dataset isn't nicely prepared, then there are options there for center crop and also to apply a horizontal flip. The miscellaneous options there allow you to use a different VAE, or if you want to train on lots of concepts, you can use a concept list. By default, this allows you to train for 3, which is perfectly fine if you are just starting out. Down in the advanced section, this is where you turn all those things on that I've been through before. So if you use LORA on, you can't use EMA, as I mentioned there. So if you've got that ticked, you are using LORA. If you haven't got that ticked, you are using the original Dreambooth. Mixed precision, I always set this to FP16, but if you've got a very old card, then you may not be able to support FP16 and you may have to use no. That will obviously use a lot more VRAM as well, but the best settings, FP16 and memory retention Xformers. Xformers is of course required for Stable Diffusion 2.1. You've got the don't cache latents option as well. If you don't cache the latents, it can be a little bit faster. If you do cache the latents, then you save a little bit of VRAM. You can opt to train the text encoder or not. Generally, it's better quality if you do train the text encoder, but it does require a bit more VRAM. Pad tokens, an extremely mysterious option. It will pad tokens if you tick that. Personally, I haven't had it ticked and it seems fine. Shuffle tags is for when you're using file words. And finally, you've got gradient accumulation and gradient checkpointing. I tend to leave that ticked and the gradient accumulation steps on 1. Gradient checkpointing does save a fair amount of VRAM. The Adam Advanced section, you can just completely ignore. All the defaults there are absolutely fine. And then before you can start training, you of course need to set up your concepts. Maximum training steps there. If you use that as -1, that will just use your parameters. So I tend to leave that as -1. Your dataset directory, point that to your dataset. I created a dataset from Pixabay here from this particular provider, and As you can see, there are lots and lots of nice pictures there that you can use. So I thought, yes, I can make 10 images out of that very nicely. And here are the 10 images that I decided to go with. As you can also see in the directory listing there, I have got a text file with the same name as each of the images that will contain the file words that describe the contents of each image. For example, with this image, I've got a text file that says a dark photograph of made up name. There are some leaves in the background. And there it is, got the text that goes with the image. If you do want to use prior preservation, then there's an optional path there you can specify for the classification dataset directory. If you're not using prior preservation, you can just ignore anything related to class. As you've already seen, I'm actually using a name as a token. I'll go into that in a little bit more detail in a moment. Prompts there, you can specify your different prompts, so you don't need to specify the file words at all. You can just specify a prompt down there. Here's an example. If you did want to specify a prompt, for example, there I've got photo of Ollis person, and the class prompt would be photo of a person, the token in this instance being Ollis. For generating images, you've got a number of options there if you want to use a negative prompt, a prompt for the sample image, and various other options. Now, it's probably worth mentioning the training wizard buttons at this point. You've got a training wizard person and a training wizard object style. If you have set your dataset directory already, you can press this button. Now, if I press training wizard object style, as you can see, not very much has changed, but it has changed this parameter here, the training steps, to 250. I'll scroll down again, press training wizard person. There we go. We've got that changed to 100 images. So basically for person, it is going to use prior preservation, and that's how you turn it on, by specifying a number of class images. When do you need to use prior preservation? Well, it does mention people there, person, faces, portraits, things like that. Basically, if you find everyone in your dataset is starting to look like your training data and you don't want that, then try turning prior preservation on, and that will keep the original diversity of faces in your model. If you're not using people, faces, things like that, then typically you don't need to turn prior preservation on. Now, you might have noticed that I used a proper name for my token, and this is a little bit weird, but I still don't really know what the best option is for these. I've tried single tokens, and personally I prefer names. So here is a list of up to 4 character single tokens. Again, links down in the description. So that's why I picked Ollis face in that particular example, because there is one line of thinking that says if you're going to use Dreambooth, then you need to use a single token, and it needs to be a fairly rare token. This is a list of all the single tokens up to 4 characters, and as it goes down, the token gets more rare. As mentioned, personally, I've found that when I'm training a person, I just use their name because that's how it was trained originally. It knows names, it recognizes celebrities and things like that. So if I'm adding a new person, why don't I just give them a new name? And it seemed to work okay. It also makes a little bit more sense when you're prompting it as well. You can add your character's name and you understand it more when you're reading it. Now you're all ready to go. You've created your model, you've set your parameters, you've set your concepts, one or more, and then you can just click the train button. If you're using the original Dreambooth, so you don't have LORA ticked, then that will run through and automatically create the checkpoint for you. If you do have LORA ticked, what you're going to need to do is once it's finished, you'll be able to select your LORA model over there. So there you can select your LORA model, and that will allow you to then click generate checkpoint, and that will create a new checkpoint. Now, one thing to note is that when you save parameters and load parameters, it will automatically untick this save checkpoint to subdirectory, which I like. So each time you load, you will have to recheck save checkpoint to subdirectory, and it will save it with the model name or custom model name that you've given it there. To test each of the models, all of the results, I set up a variety of different prompts. As you can see here, I've got a portrait photo, so that should be more like the original training data, an anime cartoon style, so that's to see if it can be styled, how strong the training data is, whether it's overtrained or undertrained. I've also got a fictional superhero, so that's doing it in different poses and armor and things on. I've got another one here that's a sci-fi cyborg look, so that's turning the person into an android. An impressionist art style painting of the concept, also a Bauhaus art style painting as well, and finally a fantasy art style photo painting, mixing styles together and producing something a little bit different. This first set of outputs is from the EMA checkpoint, but I didn't use or extract EMA. As you can see, the photo is pretty realistic. It's done a good job of transferring that face. If we have a look at the anime style image, it seems to have captured the hair there quite a lot. Not much like the original concept, but I did ask for anime. For the superhero, we've got a fine suit of armor there. The hair all seems very good. Facial features, similar. It's not exact, but it is very close. For the android with implants, we've lost all the hair, and we've got some of the facial features there, so I think that did pretty well. And the impressionist painting looks very nice. It's got the concept hair. That looks fairly similar. That's a nice representation. And for the oil on canvas version, again, we've got the hair. It looks fairly similar. It's taken a lot of the features of the concept. And finally, for this model, the lightning version. I think that one came out very well, don't you? Next up, again, remember I'm using the same prompts for all of these, but this is the different model. So I'm using the EMA model, but this time I did extract EMA and I did tick the use EMA checkpoints. There's a little bit of variation here. As you can see, the output image is very similar to the original, so it's also done a good job. The anime version, also very nice. It's got the concept hair, looks pretty good. For the superhero, we've got a slightly different pose, a little bit plasticky, not so much of the armor going on, but it has got a fair representation of the concept. For the cyborg, this one is very zoomed in, but we do seem to have the face, and we've got the concept hair and also the cybernetics. For the impressionist art painting, I kind of preferred the other one, but that one looks very nice as well. And for the oil on canvas, fairly similar to the other one, difficult to tell between the two. And finally, for the lightning shot, again, I think that has come out very good. And for the third set of tests, this is the non-EMA Stable Diffusion 2.1 checkpoint. How did this turn out? Well, once again, I think it's pretty good. The anime version also has the concept's hair. The superhero version, again, has the concept's hair. The armor could be a bit better, but still pretty good. For the android, once again, we've lost the hair and we've got lots of implants, but it does seem fairly similar, given it's meant to be an android, to the original concept. For the impressionist art painting, I like that one quite a lot. That's quite good. And the oil on canvas version is also very good and slightly different this time. I sort of prefer that one a bit. And finally, the lightning test, again, very similar to the original concept. I think that has done very well. That's all the data for the original Dreambooth. As you can see, it doesn't seem to make much difference whether you use EMA, the EMA checkpoint, have it on or off. There are some differences, but as regards to does it affect quality, I'll leave that to you to decide. Now let's take a look at the LORA Dreambooth. Already we can see this very first photo is very different, but it has managed to capture a lot of the concept. The anime version does indeed still have that concept hair, and I think that's turned out very nice. The superhero in armor also turned out very well, but the face is quite different to the concept, but it's similar. You can see the similarities. The armor's very nice though. The cyborg, a little bit off to the side, but very cybernetic. It has got many features from the concept, and it is certainly a cyborg. For the impressionist art style painting, once again, it's got the concept hair. It seems to recognize hair very well, and I think the output is quite nice. For the oil on canvas, again, the face seems to have changed quite a lot, but it does have some features of the original concept. Of course, we're asking for an oil on canvas here, so it's not going to be like the photo. And finally, the lightning pose. There it is. Not too bad for LORA, not too bad. It is fairly similar to the original concept. Alright, so how much difference does that low VRAM setting make? This one that was done in around 5 gig. This is the LORA with the minimal settings. As you can see, the photograph is indeed fairly similar to the original concept. We've got the right coloured hair. It's not done too badly. The anime version, as you can see, very, very different. It's not quite the cartoon style. It's more a sort of 3D render, but it's still a fair output. For the superhero, we've got a fairly similar pose. Once again, the hair, the face, a little bit different, but you can see features from the concept there, and the armor is still very nice. For the cyborg, this time we do have only a little tiny amount of cybernetics, sort of down there around the neck. The rest of it is most of the face from the concept. The impressionist art style painting, It's a little bit more realistic than Impressionist art style, so not my favourite one there. And similar with the Bauhaus art style oil on canvas painting, once again, it's a little bit painting style, but I much preferred the others. And the same goes for the lightning pose. We're completely missing the lightning, but features from the concept are fairly well preserved. As you can see from that, although you can run this training in a fairly low amount of VRAM, it does impact the quality reasonably significantly. And some other things to note, the extension obviously is a little bit behind the ones that it's built off, so if you go to the original LORA repository, you'll see it's got things like pivotal tuning and all this new stuff that isn't, as of making this video, quite in the extension as yet, but you can see there are lots of things in the pipeline. The extension works in a similar way to the original repositories, but it has got that one-click install, which is a little bit easier. Of course, the web interface it provides is a lot more confusing than just running one simple command, but that's just the way with all web interfaces. Additionally, that initial process of first creating the model is a little bit different from the original repos and maybe a bit confusing. And if you use Dreambooth, obviously you'll have to recreate that model again each time, as LORA doesn't change it, but the original Dreambooth does. So you may find yourself eating a little bit of disk space there with all that recreation. Overall though, I think some very good results, nice and easy to install that extension, and with LORA it's much easier to share those 6 meg files. As for which gives the best results, well, I'll leave that up to you. Here is a quick summary of those results, just doing a little side by side there of all the different options that I went through. So we've got the original model there with EMA, without EMA, and the LORA versions as well. Entirely up to you which ones you prefer. And if you're looking to make some videos with your lovely new trained model, then have a look at this video.